In this video, I would like to introduce you to spherical coordinates. So let's quickly review the Cartesian coordinate system. So in the Cartesian coordinate system, we have three axes. So we have the x-axis, we have the y-axis, and we have the z-axis. And each axis makes a right angle with the other two. So if we have a point here in the three-dimensional space, and let's call that point P, so it has coordinates x, y, and z. And let's call this point, this is the origin, so coordinates 0, 0, and 0. And let's call this point O. So x is the length of the projection from the point P to the YZ plane. Similarly, if we project this point onto the XY plane, let's call this P1, then the distance from P1 to the y-axis, that's the length of the coordinate x. The length of the projection from P1 to the x-axis, that is the coordinate y. And then the distance P to P1, essentially the height of P above the xy plane, that is the coordinate z. So this distance here equals to z. So in the spherical coordinate system, we have three different parameters. Let's call them r, theta, and phi. So what are those? So if we connect the origin to our point P, that line here, the distance of that segment is the r, we call that the radius r. And then the angle that that line makes with the z-axis, that is our angle theta. And then we said if we project our point P onto the xy plane, and let's connect a line from the origin to our point P1, the angle that that line makes with the x-axis, that is our angle phi. So to repeat, r, that's simply the distance from the point to the origin, the length of this segment here. The angle that that line makes with the z-axis, that is the angle theta. And then the projection of P onto the xy plane, the angle that that line makes, if you connect the projection to the origin, the angle that that line makes with the x-axis, that is our angle phi. So let's see how can we convert from one coordinate system to the other. So let's start with converting x, y, and z, and we want to come up with the equivalent representation in the spherical coordinate system, r, theta, and phi. So let's call the length from O to P1, let's call that R1. And let's look at the triangle, let's call the projection from P1 onto the x-axis. Let's call this point P2. So we'll look at the triangle O, P2, P1, and let's draw that outside here. So this is P1, this is the origin, and this is P2, and this is a right angle triangle. The length of this side equals to y. The length from O to P2, well, that's just the coordinate x, so this has a length of x, and then O to P1, we call that distance r1. So this is a right angle triangle, so r1 equals the square root of x squared plus y squared. Now let's look at the triangle O, P1 to P. So O, P1, and then P. So P to P1, that line is perpendicular to the xy plane, so this is a right angle triangle. OP1, we just said we call that R1. And then the length from P to P1, that's the z-coordinate of our point P. And we're trying to find R. So again, it's a right angle triangle, so R equals the square root of R1 squared plus z squared. But we know that R1 squared equals x squared plus y squared. That means r equals the square root of x squared plus y squared plus z squared. So essentially we applied Pythagoras theorem twice. Once using x, y to get the length of this distance r1, and then in the bigger, in this other triangle, we use it a second time essentially to get to r. So r equals the square root of x squared plus y squared plus z squared. How about theta? So theta equals, okay, if we take a look, let's project the line P onto the z-axis. So, and let's call this point P3. So the length O to P3, well, that's just the z-coordinate of our point here. And then the projection makes a right angle triangle. So let's draw this outside. So this is P, this is P3, and this is the origin. So this is a right angle triangle. This side here, O to P3, we said that's just the z-coordinate of our point. P to P3, well, the length of this segment here, well, that's the same length from O to P1. So this is R1, and this is our angle theta, and O to P, we call that distance R. So we can see that cosine theta equals z over R. So cosine theta equals z over r, or equals z divided by the square root of x squared plus y squared plus z squared. How about phi? So if we go back to this triangle O, P2, P1, so the angle between O and P1 and O and P2, this is phi. This is the angle here, phi, between O, P1, which is here, and the x-axis, and P2 lies along the x-axis. So cosine phi, or actually you could say tan phi, equals y over x. So we know x, y, z, so we can come up with the corresponding r, theta, and phi. Now, how about the other way around? So if we have r, theta, and phi, and we want to go to x, y, and z. So if we have r, so let's look. So if we look at this triangle, O, P3, and P. So if we have r and we have theta, then r1 equals r sine theta. So first r1 equals r sine theta. What's the relation between x, y, and r1? So x equals r1 cosine phi. That means is equal to r sine theta cosine phi. So we substituted r1 equals r sine theta. We put that term here. Y equals, so if we look at the triangle, y equals r1 sine phi. So y1 equals r1 sine phi. That equals r sine theta sine phi. How about z? So if you look at the triangle O, P3, P, so if we know r, then z is simply, we have the equation here, z equals r cosine theta. So z equals r cosine theta. So these are our equations here. So if we have r, theta, and phi, we can convert those to the corresponding x, y, and z.